Hi class, so continuing with model identification that we saw in the previous class, right? We just plot the data, check for stationarity, plot ECF, PCF and try to determine what is the model. Now in this first example, we see a non-seasonal time series data. Sorry. So the following example looks at the number of users logged on to internet server over 100 minutes of period, right? So we have the ACF, PCF also. So see, this is a simple data that is being plotted, right? So for example, you can see some pattern here, right? And there is a trend which is increasing here. Fine. So now let us do the ACF. So see, this is autocorrelation, right? So this is the ACF and then this is the PACF, right? So you see a significant bar here, which is above 95, and then you have a damped spikes, right? And it is exponential decaying. Again, you can see there is a exponential drop of the spikes here, but there are many which are significant. 1, 2, 3, 4, 5, and almost 6, right? So you can see that there are 6 spikes which are significant in this data. So you can see that the gradual decline of ACF values indicates non-stationarity, right? So you can see we have a gradual decline here. So this indicates towards non-stationary, and even on seeing the graph, we can know that this is a not a stationary graph, right? The mean changes, the variance also changes. Second thing, the first partial autocorrelation is very dominant and close to 1, again indicating non-stationarity, right? So you can also, if you have a data, you can also run the ADF test and all, Dickey-Fuller test. So the time series plot clearly indicates a non-stationary wave that we just discussed, right? From the graph itself, you can see that the graph is a non-stationary one. Now we take the first differences of the data. Now since we know that the data is non-stationary, we take the first differences and reanalyze it. So after taking the first differences, you can see it can be treated as a stationary to some point. So you can say from 0, the mean is around the same, but there are some spikes which are being still observed. Let us see the ACF. So ACF, now you can see we have 1, 2, 3 and 4, right? We have 4 ACF indicating maybe a possible MA4 model, right? And then we have 3 spikes here in the PACF. So ACF shows a mixture of exponential decay and a sine wave pattern. So you can see this is like a sine wave, this falls, then increase, right? So kind of a sine wave pattern, and also this is also decaying, right? So PACF shows significant PACF values. How many significant? 1, 2 and 3, right? Because all other lines are below the 95% interval. So this suggests an AR3 model. So now here is the fact. See, when you do time series, you can have only a rough idea by seeing the plots, right? It cannot guarantee it. So for example, in this particular case, if you see the ACF, we have 4 significant spikes, right? And then the data falls within this. So it is possible that you can have a model which, so for example, this basically indicates a MA of 4, right? This indicates AR because it is partial autocorrelation. This indicates a AR of 3. So there are many models actually possible here. So you can have only AR3, right? You can have only MA4, and you can also try ARMA, right? You can try a ARMA model with ARS3, difference of 0, and this. Also, if you see in this particular case, you have done a differencing of 1, right? So you can see I have kept an ARIMA model because the differencing is 1. I have kept 1 in all the 3 cases. Here I am only taking the PACF, right? We had PACF as 3, so I am keeping this as 3, and MA. Despite having an MA of 4, I am trying with a value of 0 just to evaluate the model. Then ARIMA, now I'm ignoring the PACF. I am keeping the 1 difference because we did take 1 difference, and then I'm keeping the ACF value 1, 2, 3 and 4. And then I'm combining these two models to have a model 314. Now the thing is that you need to try different models, right? So as you increase this, so for example, as these has a total of 3 plus 1, 4 parameters plus some constant. This has 1 plus 4, some 5 parameters, and this has 3 plus 1, 4 plus 4, 8 plus some constant, right? I'm just taking a vague example, right? So as the number of parameters increase, the complexity of the model increases. So there is no issue. Usually on a normal cases, you get a better fit with more complex model, but it may also lead to a overfitting also. So you may overfit the training data, and then you may have a poor result on the test data itself, right? So this was the first example of model identification, that how do you see a model and interpret it locally just by observing the ACF and PCF. More example will be in the next class. Thank you class for